Hey there, welcome to Solve My Math Homework. We're the YouTube channel that solves the problems our subscribers send in. So today we're looking at a related rate problem. Related rate problems are always word problems. You're looking at something that's changing in position. You're given one rate and you're asked to find another rate that is related to it, hence the term related rates. So let's look at what we have. It says we have a 13-foot ladder and it's resting against a building. So it's resting against a building or a wall. It's a fixed value, right? The ladder is not going to change in size. The bottom of the ladder is slipping away from the wall, okay, at a rate of 4 feet per second. So we have this horizontal movement, okay, where it's slipping away from the building at a rate of 4 feet per second. I hate this diagram because their X and Y labels are all messed up. So we're going to ignore that. We'll draw our own diagram. Just want you to see the movement that we're talking about as we read the problem, okay? So as you move away from this building, as you have this vertical or this horizontal movement, you also have a vertical movement. The ladder will also be slipping down the wall as it moves away from the wall. And that's what we're going to solve for. It says determine the rate at which the ladder is sliding down at a specific point when x equals 12. So basically when the ladder is exactly 12 feet from the wall, how fast is it moving down the wall? All right, so let's get into an acronym that you can always use to solve these. Okay, it's super helpful, super cute, easy to remember. I remember distinctly my calculus teacher walking into the classroom with a big dreadlock wig on, and I remember it to this day, and that was so many years ago. So the first thing we're going to do is draw a diagram, but we're going to draw a good diagram, not like the one the problem gave us. Then we're going to label our rates. And so we're going to do this kind of at the same time. We'll label our diagram and then talk about rates. Rates are the things that are moving. So anything that is moving, changing position, it's going to get labeled with a rate. And when we say rate, rate in calculus means movement. Movement means derivative, right? The rate, the change of y over with relation to time. So dy dt, dx dt. Okay, remember derivatives, instantaneous velocity involves movement. Anything that's moving is a rate. Anything that's moving gets labeled with a dy dt, dx dt, whatever you have, whatever variables you have. Okay, so then we're going to write an equation. We are not going to come up with an equation out of thin air. It's going to be something we know. It's going to be area, volume, Pythagorean theorem. It's going to be a known relationship. Then we will derive, and then we will substitute all the information back in. Okay, so let's get started. This is definitely not enough room, so we'll go to a new page. Okay? All right. So dreads. The first thing we're going to do is our diagram. And we really did see the diagram already, so we're just going to do it again. Okay, and so we have this ladder that's 13 feet. Okay, we have this horizontal movement. It's moving away from the wall. And we know that rate. And so if you're moving away from the wall, that's a change in horizontal distance. That's going to be our dx dt. And that is going to be 4 because it's 4 feet per second. Okay, we have some more movement happening. The movement as it slides away from the wall, it is also sliding down the wall. That's going to be the change in y. How fast is my vertical distance changing with respect to time? Okay, and all of this we want to happen. We want to determine the rate at which it's sliding down the wall when our distance here, x equals 12. Okay, so we want to know specifically when it's exactly 12 feet from the wall, how fast is it moving down the wall? So then we will need our vertical distance y. Okay, so that's something we're going to have to solve for. So as we look at these, hopefully we can think, all right, I've drawn my diagram, I've labeled my rates, anything that is moving is a rate, and I kind of see a triangle, right? Hopefully we see a right triangle. And the first thing you think of when we see a triangle is x squared plus y squared equals our hypotenuse squared, which is 13. Okay? So as I said before, we have an x, right? Let's look at this. We have an x value we can plug in. We don't have a y value. And so when we derive this, we're going to have a dx dt, right? When we derive x squared, we'll get a dx dt. When we derive y squared, we'll get a dy dt. And dy dt is what we're solving for. So we can't have two things that we're solving for. We need to have a y value. And we can find that with our Pythagorean theorem. And you might be thinking, hey, Jackie, guess what? This is a 5, 12, 13 right triangle. I know my Pythagorean triples. And you're correct. It is going to be 5. But if you didn't know that, we could solve it really easily. So we know x is 12, so 12 squared is 144. plus y squared, which we don't know, equals 169. Okay, so then y squared is going to be equal to 169 minus 144. So it's going to be equal to 25, right? Y squared is equal to 25. Therefore, y equals 5. Okay, so I can go ahead and put that y equals 5 into my diagram. And now you see how I got it. Okay, so I'm going to get rid of all this work because I don't really need it anymore. Most of you probably already knew what y was, but just in case. All right, so now we have, let's see what we've done. We have for sure drawn a diagram, labeled rates, came up with an equation, found all of the variables we need. We are ready to derive this thing. Okay, so when we derive, we are going to just use our power rule. It's pretty easy. So x squared is 2x dx dt. Don't forget your differential with these. Okay, plus 2y dy dt equals 169. Okay, getting a little sloppy, but that's all right. So we have done the derivative. Actually, we have not done the derivative. What's the derivative of a constant? Derivative of a constant is 0. So derivative of x squared is 2x dx, derivative of y squared is 2y dy td, and the derivative of 13 squared is just 169. The derivative of a constant is 0. Okay, now we've really done the derivative, and so we can go ahead and substitute our information in. I think I'm going to substitute and then go to a new page. So 2x dx dt is going to be 2 times, what's our x? It's 12. What's our dx dt is 4, plus 2 times y, what's our y? 2 times 5 dy dt equals 0. Okay, now it's time to open up the calculator, although I'm pretty sure we know 2 times 12 times 4 and all of that. But it's always better to use a calculator rather than to make a stupid mistake, right? All right, so let's see what we get, and let's give ourselves another page. Yeah, let's give ourselves another page. Let's do this math first. Okay, so this is going to be 2 times 12 is 24 times 4, so that's 96 plus 10 y prime equals 0. I like y prime other than dy dt. You can keep it dy dt, but I was running out of room, so let's be honest, that's why I did that. Okay, so new page. I don't need dreads on this page. Okay, so we have 96 plus 10 y prime equals 0. Okay, so what are we solving for? We're solving for y prime, or dy dt. So then we get 10 y prime equals negative 96. Okay, so we'll divide by 10, divide by 10. Y prime equals, we're dividing by 10, we don't even need a calculator, negative 9.6 feet per second. Okay, remember, we're finding the rate at which the ladder is sliding down the wall. So does it make sense that it's negative? Well, sure, it's moving downward, right? You're losing position. So it's moving down at negative 9.6 feet per second, that it's moving down the wall. Okay, I hope that helped. That was a little bit of a long problem. Remember, dreads, when you're solving related rate problems, it will always get you there. And remember, these aren't that bad. You're going to draw your diagram, label the things that are moving with dy dt or dx dt, and you're going to substitute all your information into your equation once you've taken the derivative. Thanks for watching. If you have any questions, pop them in the comments section, and be sure to subscribe to our YouTube channel so that I can solve your problem when you submit it.